24. Consider the curve with equation that P and Q are constants. 1, 3 is on the curve. The tangent to the curve at A has gradient 8. So we can set up two things here. First, using the point on the curve. So 3 equals P times 1 squared plus Q times 1. Now we can find the derivative, which is 2px plus q, and the tangent at A, so the tangent at x equals 1 is going to be equal to 8. So now we can put this here, 8 equals 2p plus q, subtract, so we're going to have negative 5 equals negative p, and the q's cancel, so p is 5. Q is going to be negative 2 when you sub it into either one. I did it into that one. Find the equations of the tangent and normal at x equals 0.2. So now we have the function f at x equals 5x squared minus 2x, and we need also the derivative, which is 10x minus 2, and then we need f at 0.2, and we need the derivative at 0.2, which I'm going to use my calculator. So this is going to be negative 0.2 and 0. So we're going to have, it's basically a max or min, because the gradient at 0.2 is 0, so that means it's a horizontal line. So you're going to have like something like that. One of those anyway. So you're just going to have y is negative 0.2. That's the equation of the tangent. And then the equation of the normal is x is 0.2. So what's going on here? You've got this graph, and then this point here is 0.2, negative 0.2. So the the tangent is y equals negative 0.2, and the normal is x equals 0.2. All right, so we have the derivative is going to be negative 3 sine 2x, and then chain rule times 2, plus 2 sine x to the 1. Remember, that's sine like this. And then we have to multiply by the derivative, which is cosine x. So this is negative 6 sine 2x. This is sine 2x. So this is negative 5 sine 2x. Okay. Now, find the equation of the tangent line to the graph of f at x equals 0. So if we do the derivative at 0, sine 0 is 0, so 0. And that means that the gradient at 0 is 0, so that's going to be a min or a max again. So if we find out the function at 0, so we're going to have 3 times cosine 0, which is 1, so just 3, and then sine 0 is 0. So we are just going to have y equals 3. That is the equation of the tangent. So it's something like, well, yeah, it's min or max. In the interval, 1 normal to the graph of f has equation x equals k. Find the value of k. So we have to find the maximum or minimum here, so that the tangent is going to be 0. So it's something like this. The tangent here is 0, tangent here is 0. So the normal is going to be a vertical line, which is the x equals k. So we have to set our derivative equal to 0. So sine 2x is 0. Now, our domain is from pi over 4 to 3 pi over 4. So that's with x. So if we multiply by 2, we're going to have 3 pi over 2 and pi over 2. So when is sine 0 there between those two? It's here at pi. So we're going to have 2x equals pi. So x is pi over 2. That's going to be when the tangent is 0. So like here. So this is like pi over 2. This is the x. So the tangent is 0 here. So the normal is going to be x equals pi over 2. So I just included a picture here. So yeah, this is pi over 2 here. So it's a minimum, so the gradient is 0 there. So that's actually y equals -2. But the normal goes through pi over 2. So x is pi over 2. Okay, 26. Consider the tangent to the curve that. Find the equation of this tangent. Okay, wait, consider the tangent. Okay, so we've got y prime is 3x squared plus 8x plus 1. Now we have to find the derivative at -1. So that's going to be 3 minus 8 plus 1, so -4. That's the gradient at -1, and we have to find the function at -1. So that's going to be -1 plus 4 minus 1 minus 6. So that's going to be to -4 as well. Okay, so that means our line equation, the tangent, is going to be y plus 4. So y minus that, y, equals m x plus 1. So if I just get this equal to y, -4x minus 4, minus another 4 is -8. Okay? So we want to now, so that's the equation of the tangent at x equals -1. Okay? So now we want to set that equal to our curve and solve it without a graphing calculator, because they want to see when the coordinates, find the coordinates of the point where this tangent meets the curve again. So we have some cubic, and then we have some tangent, like, I don't know, something like that. So that's one, that's where the tangent is, and we want to find the second intersection. Okay, so we've got 0, x cubed plus 4x squared, and then we have plus 5x, and then we have, when we add 8, that's plus 2. So we can't factor this, all right? So we need to find a 0, so an x-intercept. Probably the best place to start is at 1, okay? So if we do just 1 in, so that's going to be 1 plus 4, which is 5, plus 5, which is 10, so 12, not a 0. Okay, so if we do -1, so that's going to be -1 plus 4 minus 5 plus 2. That's 0. Okay, I'm just guessing. It's usually like 1, -1, 2, -2, something like that. Okay, so this thing factors to x plus 1 because of the -1. That is a 0. And then we need to divide that. So if we do -1, and we have 1, 4, 5, 2, So 1, -1, 3, -3, 2, -2, 0. This divides it, and this is the thing you have to multiply. That's what it divides. Okay, like this. Now, so now we have, oh, and also, yeah, I did just guess, but I didn't think clearly. We know it intersects at -1. We know that the tangent meets that graph at -1, so obviously we would use -1. So this second thing factors x plus 2, x plus 1. So this actually intersects in 2 more spots. Oh, no, it doesn't. This x plus 1 is squared. So the other place it meets is at -2. So if we do into the function, we can do it into either the tangent or the x cubed one. I'm obviously doing into the tangent because that's way easier. So if we do -4 times -2, which is 8 minus 8, so 0. That's the point. Okay, so here's a picture of our cubic curve and of both. So the red is the tangent line at -1. So that's the first intersection. The other one is at 2, 0. So, yeah. Whoops. Okay. So 27. The line y equals 16x minus 9 is tangent to that curve at 1, 7. Find values of a and b. So we have, first of all, the derivative. So that's 6x squared plus 2ax plus b. The derivative at 1 is 6 plus 2a plus b. And the gradient at 1 is 16. Okay, so we have 2a plus b is 10. Now, we also know that 7, when we substitute the 0.17 into the original function, that's going to give us our other equation. So we're going to have 2 plus a plus b minus 9. So 5, 14 is a plus b. So now, solve it however you like. So we're going to have a and -4, and b is going to be 18. All right, the normal to the curve that at the point where x is 2 has equation that. Okay. So the normal to this curve, so at x equals 2. Okay. So if we have, let's substitute in 2 first. Y equals k over 2 plus natural log 2 squared, which is 4. Okay. Now we need to find the derivative of that. So we're going to have y equals, let's just write it like this. So this is the derivative there is negative kx to the -2 plus 2 over x. Okay. So like this. Now, when x is 2, so the derivative at 2 is negative k over 4 plus 1. And the normal has this equation. So if we solve this for y, Okay, then, so this is the perpendicular gradient, so the tangent gradient is 2 over 3. So this is going to be 2 over 3 here. It's quite confusing, isn't it? So we can solve for k here. So 2/3 minus 1 is negative 1/3. Divide by negative 1. So k should be 4/3. So we didn't even really use that. Oh, wow. Okay, so f at x is that, find the values of m for which the line y equals mx plus 1 is a tangent using quadratics and discriminant. Okay, so we have to find the derivative. Okay, maybe this is method B, but whatever. 6x minus 1. So we want this to be equal to m. All right, so what we have here is some parabola, 3x squared. And then we want, so this is mx plus 1. And this is the 3x squared minus x plus 4. So we want to see when these are equal. So using so we have what m is. Okay. So m is 6x minus 1. That's the gradient. And now, if we distribute, that's 6x squared minus x plus 1 when we distribute the x. And now we're going to have this is 0, so 3x squared. Those cancel, and then minus 3. So add 3, divide by 3. X is 1 and negative 1. Okay? So it's saying like that. Positive 1 and negative 1 is m. All right, so that's method B, using quadratics and the discriminant. So that one's a bit more straightforward. We just want to see when those two are equal. So get it equal to 0. So 3x squared minus x minus mx plus 3. And now, so if we do plus x, then that's going to be negative 1 minus m. So discriminant. That's going to be b squared minus 4ac. And we want to see when they intersect. Okay, so we're going to have 1, hold on, so 1 plus 2m plus m squared when we distribute that out, and minus 36 equals 0. So m squared plus 2m minus 35 is 0. M, and 7 and 5. So m is negative, oh gosh, that's not good. M is negative 7 and 5. So that means one of these two things is wrong. Hold on. Oh, okay, it's not wrong. I just solved for m here. We're looking for m. So I have found x here, so we need to sub that back in. So 6 times 1 minus 1 is m, so that's the 5. And 6 times negative 1 minus 1 is m, and that's the negative 7.